Binomial experiments. Binomial, the prefix bi means two, right? So there's only two things that can happen, either a success or a failure. That's what makes it binomial. Okay, is we're going to have n independent trials. So independent events are what's happening. So we're not dealing with a dependent event in which the flipping of a coin affects a deck of cards. That does, they're independent events that we're dealing with. There are only two outcomes: success or failure. The probability of success, notation for that is lowercase p. So lowercase p is success, lowercase q is failure out of that. So when you're looking for p and q in these charts and things, p is success, q is failure. Probability of success, again, that is p. Q is the letter we use there. We can find either by subtracting, to find the Q, you could subtract probability of success from 1. Remember, success and failure added together for any probability type problems should add up, all the probabilities should add up to be 1. So with binomial, if you have the probability of success, then you can get probability of failure. If they give you probability of failure, then you can get probability of success by just subtracting from 1. So that makes that pretty easy. So let's fill in this chart here for the examples for that basic idea. Randomly selecting a month 30 times. Success is picking the month of January. So maybe that's what we're looking for. Failure would be not the month of January. So probability of success, how many months are there? 12. So 1 out of 12, right? Failure would be 11 of them that are not January. Okay. We know that 1 minus 1 over 12 would be 11 over 12. That's the relationship there. Randomly selecting a card 100 times. So that's the n number of trials. The success, let's say we're trying to pick a card that has a heart on it. So success would be, how many hearts are there in a deck? 13 out of 52 total. So that reduces down to 1/4. So the failure would be not picking a heart, which would be, well, if 1/4 is success, failure would be 3/4. Now that's your success and failure should always add up to be 1 for binomial. Okay. All right. Binomial probability, when we're dealing with n trials in which the success is lowercase p, q is failure, then the binomial probability that there will be exactly, so the key word here is exactly, r successes is found by using this formula. This is going to go back to the combination thing. So NCR times the probability of success to the r power times the probability of failure to the n minus r power. Okay, so we're multiplying number of combinations of getting r successes times the probability raised to the r power times failure to the n minus r power there. So it's multiplying all three of those things together. So combinations coming back in from what we did on the very first lessons there. All right, number one, let's just work through a few of these, and you'll see it's really not that hard. It's pretty straightforward. Mark tosses a coin 25 times, so our n is 25. All right, so that's what we're finding here. Is n is 25. What's the probability that it lands on heads exactly 7 times? So r is 7, right? And then n minus r will be 25 minus 7, which is 18, right? Now, what is the probability of flipping a coin that landed on heads? 1/2, right? So probability of it not landing on heads is 1/2. Okay, so we found all of these things that are going to go in our formula. Okay, know the number of trials, that's n, 25. How many successes are we looking for? Exactly 7. So that's 7 is our, we know the probability of success because it's flipping a coin. It's 1 out of 2. Probability of failure happens to be 1 out of 2 as well. Okay, just because it's a coin. All right, now, so we're going to figure out that problem. So 25, choose 7 with combination times 1/2 to the 7th power times 1/2 to the 18th power. And that's going to give us the probability of that happening exactly 7 times. All right. So math, go over to probability. We're getting the combination, 25 trials. We're looking for 7 times. That's that number. So it's 480,700 ways that could happen in 25 coin flips. All right. And then we're multiplying that times 0.5, 1/2 raised to the 7th power for success, times 0.5 raised to the 18th power for failure. Happening exactly 7 times. Success is 0.5 to the 7th power. Failure is 0.5 to the 18th power. We got to have all of those there because we're flipping the coin 25 times. So you got to take care of 7 times it landed on heads like we want and 18 times where it didn't. Okay, multiply all that together and get this nice decimal there, 0.0143. We'll go 4 decimal places there, which as a percent would be 1.43%. And again, I just be consistent. If you're going to name it with percents, use percent. If you're not, then don't. Okay. Okay. All right. Number 2, take this. Will. Yes, sir. Doesn't work as in it doesn't pull up. It doesn't give you the boxes. Is that what you're saying? Or it doesn't come up? Does yours come up and look like this in CR, like have ANS, NCR, like that? Okay, so what you need to do is type in the number of trials first. So you would type the number 25, then hit math, PRB, and it's going to put NCR right there. And then you'll type a 7 after that. And that's doing the same. That's how that thing does that. Issues in this class. Yeah, the some of the black and white ones do it that way. Let me see if I can change to the older version. Yeah, that's awesome. All right. So type the 25, math, go to PRB, and we're choosing NCR, and then we type the 7 like that and hit enter. Get you that same number there. So it's just a way the older version does the notation there. Instead of having the boxes, N's got to come first, R's got to come last. That's how you want to do that. Some folks had that problem the other day. We were doing that. So, all right, I'm gonna swap back to the color one because I like it better. All right, now, so let's look at number 2. Got a spinner, got blue, green, purple, red, yellow, and red. Spinner below is spun 10 times, so that's N. What's the probability that it lands on red exactly 6 times? So 10, choose 6. What's the probability of it landing on red? How many reds are there? 2 out of 6. So that's 1/3, right? And we want it to land 6 times. What's the probability of not landing on red? 2/3. And that's got to be how many times? It's the exponent on that. 4. We got to where how many trials are there? There are 10. So if we are looking for 6 successes, then there's got to be 4 failures out of that. We're going to multiply that all together. So I'm just going to go up here and grab that and change the numbers. 10 combination 6 times 1/3, and I'm going to use parentheses and the fraction 1/3. Don't use 0.3 because that's not the same thing. Okay. Raised to the 6th power times 2/3 raised to the 4th power. 0.0569. 5.69%. Probability of doing that. So be careful on that. On the first example, I used 0.5 because it was a terminating decimal. That's okay as long as it's a terminating decimal. If it's a repeating decimal, definitely use the fraction, not the, you can't type enough 3s or 6s in there to make it work. All right. Number 3. I like this one because it relates to you guys and what some of you do on tests. She took a multiple choice test with 4 choices for each question. She guessed at the last 5. Okay. What's the probability she got exactly 3 questions correct? Okay, so what's n? How many trials are there? 5, because that's how many she guessed on. She guessed on 5 of them. So we know n is 5. Our successes, how many of them are there? 3. So we're looking for 5 combination 3. It doesn't matter if she got the first 3 that she guessed at right or the last 3 or first, second, and last. You know, we're looking for all those combinations. Just getting 3 right. What's the probability of getting 1 right? 1 out of 4. We're just blindly guessing at that, okay? 1/4 is our successes. We need to raise that to what power? 3rd power. What's the probability of getting it wrong? 3 out of 4. So that's failure. And we need to raise that to what power? 2nd. Because remember, your exponents on success and failure got to add up to be n. Okay? If they don't add up to be n, you're not accounting for every possibility there. Okay? And we're just working that out. So 5, choose 3 times 0.25 raised to the 3rd power times 0.75 raised to the 2nd power. She has a 0.0879, 8.79% chance of getting 3 out of 5 correct. That's making a 60 on those last 3. That's not real good. So if we were going to set this up, just an extension on this problem, if we were going to set this up to guessing on the last 5 and getting all 5 correct, what changes in this problem?
3.
The 3 becomes a 5. So this 3 becomes a 5. That 3 becomes 5. What does this exponent become? 0. Because if we get all 5 of them right, we can't get any of them wrong, right? So that would be 0. So that would be the change, and you could figure out the probability of guessing on 5 questions, getting all 5 of them right. It's not very good at all. All right, so because you only got an 8% chance of getting 3 of them right. Even worse to try to get them all right. All right, let's look at Chad randomly chooses a card from a standard deck 30 times. What's the probability he gets the diamond exactly 4 times? So he's picking a card and putting it back. They don't say that, but that's what's happening, is we're picking a card and putting it back. All right. What's the probability he gets a diamond exactly 4 times? So trials is how many? 30. Successes are how many happening how many times? What's R? 4. Okay, so 30 combination 4. What's the probability of picking a diamond? 1/4. 13 out of 52, and reduce that to 1/4. We're doing that 4 times. 3/4 would be the probability of not picking a diamond. How many times are we doing that? 26 times. Definitely calculator use is handy here. Zero 604, 6.04% probability of picking a diamond exactly 4 times out of 30 tries. So we're picking this. All these examples have been for doing something exactly a certain number of times. Okay, that's what that is. All right, so let's look at maybe a little tougher situation as we deal with 30 balls are numbered 1 to 30 in a bag. One is randomly selected 12 times. What's the probability of getting a prime number exactly 5 times? So there's a lot of stuff going on in this situation. It's not any more complicated as far as setup goes. You just got a lot more numbers in there to confuse you. Okay, so here's where knowing what N and R are, and that's definitely helpful here. So 30 balls in numbered 1 to 30. One is randomly selected 12 times. There's a lot of numbers there, but which one's in? 12. What's R? 5. Okay. So first statement really didn't have anything to do with N and R. All right. So be careful of that when they throw extra numbers in there. All right. Now, so we're going to have 12. Choose 5. What's the probability of picking a prime number in the numbers 1 through 30? So what are the prime numbers in numbers 1 through 30? 2, 3, 5, 7. Well, 7 is not prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of how many? 30 balls. 10 out of 30. Which we will reduce that to 1/3. We want that to happen how many times? 5. So that means the non-prime or a composite number is going to happen how many times? 7. Crank that out. Somebody give me a decimal number for that. Go 4 decimal places. 19.07. If it's 7.5, let's go up to 8. So it'll be 0.1908. And then that'd be 19.08. 19% chance of that happening. Not bad. All right. Probability of a customer at the store receiving a coupon printed for their receipt is 1 in 8. And if 20 customers visit the store today, what's the probability that exactly 3 of them receive coupons? Okay. So let's get our stuff here. So what's N? 20. Okay. What's R? 3. What's our probability of success? So 20, choose 3. Probability of success. How many people get a coupon? Probability of customers in the store. So this first statement here is 1 in 8. And that's happening 3 times. So probability of not getting a coupon when you come up to the register, 7/8. And that's happening how many times? 17 times. Let's calculate that out. 20 combination 3, 1/8 to the 3rd power, 7/8 to the 17th power. Get us. All right. 2300, 23%. So almost 25% chance of 3 people getting that that coupon out of 20. All right. 7, game of chance. There's probability of winning is 30%. If 15 games are played, find the probability of winning exactly 6 games. So maybe a little more straightforward, but they give us the probability of winning is 30%. So how do we set that up? All right, so that'd be 15 combination 6. 3/10 or point, since that's a terminating decimal, we can do 0.3 to the what power? 6th, and then that means that Q has got to be 0.7 to the 9th power. Draw out this information. All right. What's that going to equal out to be? Decimal point something. I mean, 15 times 0.1472, 14.72. 14.72% chance of winning exactly 6 times. All right, number 8, traffic lights is red for 20 seconds, yellow for 4 seconds, and green for 36. Find the probability that within the next 12 cars that randomly arrive at the light, exactly 4 will be stopped by the red light. All right, so 12 cars. So that's what? Yeah, 12, choose 4. 12 combination 4. What's the probability of it stopping you? What's stop in this situation? Red. Some people stop on yellow. Some people do the opposite of stop on yellow, which is florid. So probability of it being red is 1/3, 20 out of 60. Because if you total up 24 and 30, 24 and 36 added together, 60 seconds is the cycle of the light, is what they're saying there. I don't think that's exactly what the light in town is at all, but this light does that. So 1/3. And then we're wanting to exactly 4 will be stopped, so that's to the 4th power. Probability of not being stopped would be to the 8th power, 2/3 to the 8th power. We're assuming none of these 12 cars show up at the same time because these are independent events. So it's just one red light, kind of like Adamsville, maybe like after 8:30. There's only a few cars on that in town. So working that out, what we get? 2, 3, 8, 4. 8, 4. 2, 3, 8, 4. 2, 3, 8, 4. And then that'd be 23.84% probability of getting stopped by that light. Exactly 4 of the next 12 cars that come up there.
You know that red lights, like at a certain point at night, they just flash. They don't like change.
Not all red lights do that. Some do. Some of them in cars do. Yeah. A lot of more of them now have the sensors that they can tell if somebody's sitting in front of it, so they cycle that way. Yeah. All right. So when we get to 9, 10, 11, and 12, it's changing the situation. It says Kyle tosses a coin 10 times, which we've done a coin toss problem. What's the probability that he gets tails at least 8 times? Okay, so at least means how many times could we get tails and it be successful? 8, 9, or 10. Could be all 3 of those, and it still be a success out of this. So when we're dealing with this one, we've got to find the probability of meeting the at least, which is 8. So that would be 10 combination 8. Probability of tossing the coin and getting tails, the success would be 1/2 to the 8th power. Failure would be 1/2 to the 2nd power. But we also have to account for, well, if we toss it and get tails 9 times, that's also what we're looking for. So at least means 8, 9, or 10. So 1/2 to the 9th power, 1/2 to the 1st power. But also we could do 10 combination 10. So we need to find all 3 of these and then add them together. So at least your minimum and anything above that, and add them up. So we got to find these probabilities.
So you only do 10.
Well, how many trials are there? We had to get from 8 all the way to 10 trials. If there were 25 trials, we'd have a whole bunch more to do. Hopefully, they don't give us one that's like that, because that'd be forever taking. So 8, 9, or 10. I wrote a 9 again. That's a 10 there. 8, 9, or 10 are possible probabilities. So probability of doing it 8 times, 0439. That's what I've got written down. 0098 of getting 9 times. Probability of getting tails 10 times is pretty slim. And then we're going to add all those together. 1, 10, 11, 12, 13, 14, 1. So 5.47% probability of getting at least 8 times of flipping a coin and getting tails. It's not very good. Number 10 is an at most problem. So at most means what? Yeah, that at a mark or less than that, right? So when you do, it's the same idea. You take your, we're looking to choose the day of the week 6 times, probability of choosing Tuesday or Thursday at most 3 times. So probability of choosing Tuesday or Thursday at most 3 times. So 6 times that trials, 3 times. What's the probability of picking a Tuesday or a Thursday? 2 out of 7 to the third power. So they leave us a 5 out of 7 to the third power. And then we're going to do the same thing, 6 combination 2, because we're going at most, so we're going to go lower. So that'd be 2 out of 7 to the second power, 5 out of 7 to the fourth power. 6 combination 2, 2 out of 7 to the first power, 5 out of 7 to the fifth power. We also have to take into account, this is the one that most people will leave out, is what if you didn't pick Tuesday or Thursday any of the times? The 0 out of that. And that should have been a 1 there. I wrote it 2. So 6 combination 0, 2 sevenths to the 0 power, 5 sevenths to the 6th power. You've got to take into account 3, 2, 1, and 0 out of that. So when you're going at most, don't forget the possibility that you might not pick your success. And then we're going to add all those up. So 0.1700 is 187. Same for that one. There's a 13.28% probability that we don't pick Tuesday or Thursday at all. And we add those up. And 8 be 2, 16, 8, 20, 2, 10, 11, 21, 24. Nope. 10, 11, 14, here's 1, 6, 7, 8, 9. Ooh, pretty good probability, 94.02%. Pretty good probability, 94%. Picking Tuesday or Thursday at most 3 times. Not too bad. Just got to keep into account what's going on there. Number 11, a soda company prints prizes inside their bottle caps. The probability of winning a prize is 1 in 3. Out of 8 bottle caps, what's the probability that at least 5 are winners? So what are we taking into account there? At least 5, so that means 5, 6, 7, and 8. So we got 4 things that we got to find there. All right. Do we need to go through that? Concept is what I'm after here. Is can you do that? All right. So there's no need in us working all those out. Y'all can do that. Number 12, 7 boys and 5 girls in the debate team. Each week, 1 is chosen at random to lead the debate. For the next 10 weeks, what is the probability that no more than 4 girls is chosen? So when we're doing no more than, what does that mean? 4 or less, right? So 0, 1, 2, 3, and 4. That is that. So you find the probabilities for those and add them up. I think you guys can do that. I don't see.
Wait, would it be 12 combinations?
How many times are we picking?
10. Okay,
10. Yeah, there are 12 people, so your probabilities are going to be based off the 12. But your trials end's going to be 10 because that's how many times we're picking somebody. Good question. Any others about those? If you want to work those out, I'll tell you what the answers are. It's 8.8% for 11, 59.08% for number 12. If you want to go through the motions of working those out, but concept, if you know how to do that, how to set it up, it's all just punch it in the calculator and let it work it out for you there. Not a major thing. All right, so I got a little practice with this. I'm going to tell you which ones to mark out.
We've seen them.
Get one of those that are, yeah, you did. All right, so when you get that, mark out numbers 1 through 4, where you're multiplying out those binomials. I'm not doing that with you guys, for the sake of time, and sanity.
Did you see where all?
You want to practice multiplying out binomials, by all means, definitely. But it's not something I want to do. So mark out numbers 1 through 4. So you're doing 5 through 14 on that to work in.
Have you seen the new Avengers Endgame movie?
I have not.
You know, Aquaman.
Aquaman, you drowned in the air if you're Aquaman, right?
That's no joke. He's also in DC.
No, I don't follow that stuff.